The James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang.
When astronomers ask, well, what's new? What did you find that we didn't know before? One of the big answers from the James Webb Space Telescope is this. The first galaxies grew differently than we expected, and we don't know why. For decades, our cosmological theories have suggested a specific timeline for the universe, one that began 13.8 billion years ago with the Big Bang. Webb was built to see the beginning of that story, the birth of the very first stars and galaxies. But the ongoing discoveries made by the Webb telescope are profoundly influencing how we comprehend the universe. What it has sent back are portraits of galaxies from the dawn of time that appear surprisingly mature. These findings have created a tension in our understanding, a puzzle that is forcing scientists to re-examine the first chapters of cosmic history. According to our standard cosmological model, known as lambda CDM, the first galaxies should have been small, somewhat chaotic, and built up gradually over hundreds of millions of years. Instead, Webb has sent back images of galaxies in the early universe that are unexpectedly bright, and in some cases, surprisingly massive and well-structured. This has led to some confusion. Early analyses suggested a paradox. Some stellar populations were estimated to have ages that were uncomfortably close to, or seemingly older than the age of the universe at that epoch. Now, it is critical to understand that this is not proof of stars existing before the universe. Instead, it's a sign that our models for interpreting the data, like how we estimate mass and age from light, might be incomplete. Recent studies, for example, show that some of these galaxies appear brighter and more massive because they host rapidly growing supermassive black holes at their centers, which adds to their light. The universe itself isn't broken, but our understanding of how quickly its first inhabitants grew is facing a serious challenge. To understand how astronomers tell time, we need to look at an effect called redshift. As the universe expands, light from distant objects gets stretched to longer, redder wavelengths. The more redshifted a galaxy is, the further away it is, and the earlier in cosmic history we are seeing it. The lambda CDM model, which is incredibly successful at explaining things like the afterglow of the Big Bang and the large-scale structure of the cosmos, provides a very specific 13.8 billion year timeline for this process. But some of Webb's discoveries are testing the assumptions within that timeline. For instance, in a paper published recently, researchers revealed the discovery of a galaxy named Alcmena. It's a stunning, grand design spiral galaxy with symmetric arms, much like our own Milky Way. However, it existed just 1.5 billion years after the Big Bang. According to our theories, such a well-organized structure should have taken billions of more years to form. As lead author Rashi Jain stated, Alcmena possesses the structural maturity we associate with galaxies that are billions of years older. Her co-author, Yogesh Wadadekar, added that this finding reveals that the early universe was capable of far more rapid galaxy assembly than we anticipated. This is not an isolated case. Further studies show a growing number of candidate massive and structured galaxies at high redshifts. While not a definitive, consistent pattern yet, these examples provide tantalizing clues that the cosmic timeline for galaxy evolution might be more compressed than we thought. So how are scientists trying to solve this? There are several possibilities. The first, and most mainstream explanation, is that our theories of galaxy formation need to be revised. It's possible that the early universe was far more efficient at building galaxies than our models predicted. Scientists believe conditions might have allowed gas to cool and form stars more rapidly, or that the first massive stars and black holes acted as powerful gravitational seeds, kickstarting galaxy growth on an accelerated schedule. This idea doesn't break our timeline of the universe. It just means the recipe for making galaxies in that timeline needs updating. A second, more radical idea is that the universe is older than we think. A physicist from the University of Ottawa, Rajendra Gupta, has proposed a model that would nearly double the age of the universe to 27.7 billion years. His model does this in part by reviving an old concept called tired light, which suggests redshift is not only from the expansion of space, but also from light losing energy over cosmic distances. This could give galaxies billions of extra years to mature. However, it is critical to state this is a fringe idea. The tired light concept has been largely refuted by numerous other observations, such as the time dilation of supernovae and the precise blackbody spectrum of the cosmic microwave background, which makes this model an unlikely solution in the view of most cosmologists. This brings us to a third, highly speculative possibility. The Big Bang was not the absolute beginning. Theories like a big bounce or a cyclic universe propose that our cosmos is one in a series. In such a scenario, structures could potentially be inherited from a prior universe. These ideas are on the outer edge of theoretical physics and currently have no direct observational evidence. They are not being widely considered as a direct solution to Webb's findings, but they represent the outer limits of what is theoretically contemplated. When astronomers ask, well, what's new? What did you find that we didn't know before? One of the big answers from the James Webb Space Telescope is this: the first galaxies grew differently than we expected, and we don't know why. What it has sent back are portraits of galaxies from the dawn of time that appear surprisingly mature. These findings have created a tension in our understanding, a puzzle that is forcing scientists to re-examine the first chapters of cosmic history. According to our standard cosmological model, known as lambda CDM, the first galaxies should have been small, somewhat chaotic, and built up gradually over hundreds of millions of years. Instead, Webb has sent back images of galaxies in the early universe that are unexpectedly bright, and in some cases, surprisingly massive and well-structured. What is becoming clear is that the early universe differs from our current expectations. It's not a crisis for cosmology, but science working as it should. The standard lambda CDM model remains a robust framework, but Webb's data is forcing a refinement of our understanding of galaxy formation within it. Whether the solution is found in more efficient star formation, a revision of our models, or something else entirely, the investigation is just beginning. The universe, it seems, is more complex and was able to assemble large structures more rapidly than our theories had fully accounted for. These surprisingly mature early galaxies are not a problem. They are a promise of deeper understanding still to come. With the James Webb Space Telescope as our eyes, we are just beginning to see the answers.